Hey everybody, my name's Ken and I am here today to talk about runtime performance. This is my talk, doing the least amount of work possible, which while not only a performance tenet is a personal value that I hold. So let's get started by asking, what is runtime performance? And you don't hear as much of it comparatively to some of the other stuff, right? A lot of the time when we're talking about performance, or when you hear from, I guess what would be DevRels or platform advocates, the performance that they're advocating for is your load performance, right? Like a lot of conversion and retention and things like that. That all boils down to how fast your site loads and your time to interactive and things like that. You have all these lighthouse metrics, and that's what's largely optimized for, right? You're seeing things, tooling like lighthouse scores, core web vitals now built into create React app, things like page weight, right? Everyone's concerned with bundle splitting and keeping your bundle sizes in control. And that also funnels into things like the time it takes to parse JavaScript. Like if you have a lot of JavaScript you're serving up, right? First contentful paints, right? You have these benchmarks of how fast your site's coming in, and most importantly, I think, is time to interactive, which is the time until someone can actually start using your app or your site. They're in the clear to get going. And while that's super important metrics, and it's very well documented, that's not what this talk is about. This is about staying interactive. Right? Once you've loaded up, once you've covered your bases, depending on what your app or your site does, what you want to do at the end of the day is continue to be interactive after you've gotten them to that meaningful checkpoint, right? And the core piece of that is to not block your main thread. In JavaScript, you have a main thread, and it's where a lot of the party goes on. And if you block it, right, you're going to see things like animations are going to jank out. You're going to be typing into inputs, and there's going to be lag. All things that adversely affect the UX of your site or app. And you don't want that, right? So the typical like issues that you might see, things like computationally expensive tasks. If you have to operate on or clone a big bunch of objects or something like that, right? Animations is where you'll see it. A lot of the time, you got to go and start typing or start trying to click something or do a hover to see it. But if you have an animation going on, you're going to see that almost immediately if it's done a certain way. So it's going to jank out. And it doesn't even have to be like 900,000 objects. You can have your whole site get janked out just by reflow, repaint, and layout. I was looking at a site for a buddy the other day, and he didn't have any JavaScript, but the site was running slow, and it was the Web Animations API. It was just browser layout taking place, right? Other things are parsing, right? If you're parsing large, buffers or JSON, right? That takes time. That's a computationally expensive task. And my least favorite of all, which you probably have the least insight into and takes real detective work, is memory leaks. They're devastating. But again, that becomes really apparent. Oftentimes not very quickly. You have to sit there for, an hour, and now the thing slows down, and then you say, oh boy, you have like a CSS problem, like you refresh and you can see like, I changed this, I changed that. With a memory leak, it's like you have to wait an hour just to reproduce it. It's rough. So how do you know that you have a performance issue? So, I mean, obviously you could profile, but a lot of the time, if it's actually an issue, you'll know. Like, as far as you hear a lot of talk about, premature optimization, things like that. if you have a performance issue, a lot of the time, it becomes pretty apparent. Your thing will be slow, unless you get used to it being slow, but that's a whole nother talk, right? Your best case scenario is you're going to see a lot of dropped frames and things like input delay, right? Those will be the main indicators that you're having a problem. Your worst case scenario is an aw snap, right? And then this is where it memmed out and, it's totally crashing your website. So those 2 points and anywhere in between, it's indicative that, you should probably take a look at the code and think about optimizing it. So how do you fix it? You've identified that, there is a problem. You're not sure what it is, but, how do you fix it? And I'll tell you right now that a lot of it is like detective work. Performance is not prescriptive in the sense that I can't tell you a checklist of things like I can with like a Lighthouse. I can't be like, well, do your bundle splitting and, put this stuff in the head and this stuff at the bottom, or, a lot of the time it's a problem that you've created the way that you've coded it. And you have to untangle that, right? And it's a thing that you have to get clever about. Sometimes it's the reality of the requirements of the app. And then you have to find a trade-off or a sneaky way to do less work, right? At the end of the day, when you're optimizing for performance, if you want it to go better, you do as little work as possible. Not you personally, your application. You want to do the smallest amount of work possible to achieve your goal. Otherwise, you have inefficiencies and, at scale, they blow up, right? So, there are some semi-prescriptive things that I can get into, right? Obviously, it has to apply to your situation, but things like using a regular for loop is, if you're saying, hey, this takes too long, how can I make it go faster, right? Where can I get a little here, right? If you're sitting here getting all fancy with all these chained, maps and all this and that, if you do it in a regular for loop, at the scale where it would matter, you can absolutely get some of your time back using that. A lot of array operations, right? Like if you're doing like a find in an array or something like that, right? One of your biggest enemies in performance optimization is iteration, especially unnecessary iteration. So if you have an array of like 500,000 items and you're going to go do a find on it, or you're going to do any of these array prototype operations that are going to run through the entire thing until it either exits or completes, that's expensive, right? So if you have like an ID, say, I have this ID, I want to find this row has this ID. You can create a lookup table, and a lookup table is a stupid term for, maybe not a stupid term, but if, what it is it's an object, right? Where the key, right, would be your key, like an ID, like the thing you want to look for, right? And then you could have the value of that be the index position of your thing in the array, right? So it's a very cheap way to find that thing. Right. So you're saying like, oh, well, I have to update thing ID equals this, say, hey, lookup table, where is it? And it just bap, 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 bap. And then you're good to go, rather than saying like find with a predicate function that looks for the ID or something like that. Another thing that you want to check out, especially costly, is creating a bunch of new objects. And that's objects and arrays, right? There's a lot of fanciness going on in dev these days with ES6 or Next or whatever we're calling it these days, where you use spreads all the time, and spreads create new objects, right? So if you're dealing with things on the magnitude scale of hundreds of thousands of things, and you're creating new objects, what that's going to do is that's going to force garbage collection. and its allocation cost as well, but that is gonna hose your stuff, right? If you can do a direct mutation, and I know it's a dirty word, but if you can do a direct mutation then you can see some savings. An alternative is to use something like Immer, where you have a structural sharing, right, where it's not performing a clone to do an update, right? It's not necessarily mutation or imperative, but it's a way to do it that's much cheaper. One thing that's really funny that I want to talk about for a second is perceived performance, right? So there's performance where things are actually slow and actually blocking the main thread, but there's also scenarios where you can make things feel faster without it actually ever being faster, and you could do that by turning off animation in a lot of cases, right? So if you I had an app where I was redesigning it, and people were like, wow, it is blazing fast right now, what did you do? And I just turned off animation, right? If you have this like animated hover type thing, while it looks cool, right, the perception as you're going through is that it's slower. If everything is instant feedback, right, it feels faster. So perceived performance, that's kind of like you go back to like the suspense with the loading spinner thing. There's something to be said for perceived performance, especially in the UX area. Another thing I might go into is to avoid reflows and layouts, and I'll show that in a little bit how that can happen. But you don't even need expensive things to be happening. If you're animating things or popping things in and out, and it is causing the browser to redraw, then that's not great. That doesn't even need computation. It gets the browser redraw itself will jank everything out. Caching is an easy way to improve your runtime performance. A lot of the time you'll see on every single render, people will call a date format or something like that, right? And a date format is expensive, or create a date object. If you can memoize that, if they're not changing and you don't expect to like rack up like this like 2 GB cache of date objects, then what you're doing, it's a sneaky trick, right? Where you're saying, I'm going to format these dates once, and then any subsequent call to format for that date, right? If we're rendering this, if we're clicking a checkbox and it's just enabled or not, it has nothing to do with the date changing, right? It's just gonna serve up the string, bap bap, right? And you're not gonna take this hit on every single item getting date formatted. And then there's minutia, right? And the minutia isn't a lot of the time it's overkill, right? But when you're really grabbing for stuff, right, they're really like, especially in large row count iteration kind of things, doing something like if you're gonna delete a bunch of things out of an object, right, like it's way faster to set it to undefined instead of using the actual delete keyword. And like anything else in performance, there's a trade-off where it's like those things are still going to come up in like has own property or something like that, but that then you just have to be wary of it, because there is a trade-off for everything. So I want to talk just for probably the rest of this talk about profiling, because that's how you're going to solve these issues. And outside of the semi-prescriptive stuff that I just mentioned, you want to find your issue and identify it so you can begin architecting a solution to it, right? And some of the tools that I'm going to show and that we're going to use are the Chrome Performance tab, the Chrome Memory tab for memory leaks, your Performance Monitor, which is very helpful with CPU, and the UserTiming API, which is amazing, right? So let's learn how to use DevTools a little bit. So I have this little create React app business going on here. And in here, I'm going to create, a million rows in an array here in this initial list. And then we're just going to push them, right? And then I was going to live code it, but I'm not going to do that right now because we're running out of time and I want to get to this. Whoop. So we have this list, this initial list, million things, right? It's got an ID and a value that's random. And then we're just going to use that as state here with the initial value, right? Then on mount, right, our use effect, I'm going to do an interval. Every 500 milliseconds, what I'm going to do is I'm going to call set list with our list, right? So this is a set state, right, with the list. I'm going to spread out that list, clone it to create this new list. And then I'm going to iterate through and spread the old values in this spread. Remember what I said about the spreads. So this, now it'll get its ID, which, is ridiculous because it's just the index, but it's contrived. Bear with me. And then we're just going to add a new value, and then we're going to return the new list. So we're updating that list here every 500 milliseconds of a million things, right? So let's take a look at this. And I'm going to show you how do we profile this, right? So we have our slow app here. So I'm going to bust open my dev tools here, and we're going to take a look because we're going to learn how to read this today. You hit record, all right, and it's going to start profiling your runtime performance. You hit stop. And now we can look in here, and if you see, so first of all, this is your main thread. I'm going to just walk through this for a second. This is your your raster, your GPU, your compositor. If you have workers, that'll be on a separate line. Wow, it's having a really bad time here. I might drop that count down. So each one of these right here is one of those updates that you're seeing, and it is going to it's going to go from parent to child in the call, right? So you're going to see I have this anonymous function here. It's going to run through a bunch of internal React stuff. It's going to try to render app, right, in response to the state thing. We get down here into our state reducer. This is the actual internals of that. And then you're going to see this. These are all anonymous because it's not a named function, the reducer on that set list. But you're seeing this, and when we're creating that many new objects, that's where you get this garbage collection that's taking 10 milliseconds, right? So in order to do that, right, we're looking at 375 milliseconds. Like when you look up here and you see this red up here, that means when you're actually blocked, right? And you'll see down here, it's going to say total blocking time. So it'll show you that. And you have an enormous amount of missed frames in here. The red is bad. And if we go and look, I think it's having a pretty bad time right now. So we can go to more tools, and we can go to performance monitor, right? And it's going to tell us that we're almost at 100% CPU here and there. The heap is humongounoid, not that many DOM nodes. So let's go back for a second. I'm gonna take this down to like 20,000. All right, and then we can come over here, and it's not so bad anymore. It's orders of magnitude less, but it's still not great. We're gonna come in. We're gonna run a profile again. All right. So for less things, it's not as bad, but it's still pretty bad. It's 60 milliseconds. That's like several dropped frames. We can go and look at memory here. And this is how you debug memory leaks, right? If you take a snapshot here, a heap snapshot, one common way that I'll do that. There's a lot of objects in here, so it's thinking, and I'm screen sharing. God, relax. So you have here, and then what you can do is you can sort by shallow or retain size, and then if you take subsequent snapshots, you can go through and you can see what is happening, what's more. You can even go and you can if you do 2, right, there's like a diff. Right, I'm not going to do it again because it takes a while to do, but see this, you can see objects allocated before snapshots. So you can look at the diffs of, what is accumulating in here, and that's pretty helpful. So here, right, we know that our problem is, in this anonymous function, but the problem is that this kind of gets like quantized into these blocks. So what we'd want to do is take a look at the minutia. And the way that we would do that, what I'm going to do is I'm going to do 5,000 just so it's not so devastating. But what we can do here is we're going to use what's called the UserTiming API, and it's amazing. So you can do performance.mark, right? And we'll call it list clone start. And then we can come down here and I can say performance.mark list clone stop, right? And then right here, I can say for each one of these, well, before I do that, I'll say performance.measure, right? And you have your measure name, so we're going to call it list clone. And then you have your beginning and end, which are going to be list clone start and list clone stop. Down here, I'll say performance.mark, and we'll just call this 1, 2, right? And we'll call it 1 and 2, right? And I can hit save there. And then we can come back here. It's probably going to yell at me. Let's refresh you. Come back here, and rather than that bucketing into the wild stuff, we're actually going to be able to see granularly what's happening here, which is going to help you in your profiling. This might take a second. You can do it. You can do it. I believe in you. All right, I'm going to do a quicker one. Nobody's got time for that. Come here, you. Okay, now we're talking business. Okay, so here, now above main, you see a new thing called timings, right? And previously, when we looked over here and we look down here and we see these anonymous, right? That's where it topped out. Now you get to see granularly what's happening in here, right? So you have mark, measure, yeah, that's in there. But if we go up top into timings here, we can zoom in and we can see exactly how long these things take, right? Like this is an iteration, right? So you see the 1, 2 iteration, and that's in microseconds. I'm trying to see if I could see one of the clones. It's probably in the beginning here. Yeah, see that? So you see the list clone takes a fraction of a millisecond. Obviously, if we were up at 1 million, there'd be quite a few of these, and I'd probably just do the clone rather than the individual ones. But yeah, this is a great way where you can granularly take a look at what's causing problems. Now I'm already over time, but before I bounce, I'm gonna show you an example of when it's not even JavaScript that's doing it, right? So before, and let's take a look at, like, when we go here, right, you're seeing some information in the summary right here, and then it's going to say the aggregated time, and it's almost all scripting, right? So that's telling you like your JavaScript's the problem. But a lot of the time, JavaScript is not the only culprit here. So we have this rascal rotating, and this animation takes place on a different thread, so it's not a problem, right? It's also using transform, right? So it's composited, which means it's drawn as like a layer on top of your website. When you use like translate or rotate, it's not actually updating layout. It's not moving things around on the screen. It's kind of just like in place. So if you translate, right, like the area where it is still there. It's just up, right? Because it's being composited, right? So you don't take the perf hit there. And then that's why they say to use the transforms if you don't want it to be janky. But if I come here and I do a layout forcing thing, like if I were to animate height, for example. So if I were to come here and I was going to say height, and we're going to go like 200 pixels, height to 400 pixels, right? And we come over here, right? You're going to see it kind of jank out, right? You might not be able to see it on the stream jank out, but what's happening is when this gets bigger, every single time the browser's internal layout system has to recalculate where all this shit is supposed to go. So if I come back over here and now we profile this, it's going to tell a very different story. Probably not as clearly as it did with the more expensive things. But if we come in here, right, what you're going to see is a lot of green and purple. Right, and what that is, and see all these drop frames? What's happening is this is style recalculation and layout and then repainting, which means the browser constantly has to redraw the entire thing that you're looking at because the height is changing, which is invalidating the layout. And you can see in here, it's saying rendering, painting, and not just that, you can see the compositor here is going absolutely bananas. You're getting GPU hits over here on the paints, right? So you don't need JavaScript to destroy your runtime performance. You can do that all your own, just with CSS. So I hope that today I've done a good job of putting the spotlight on runtime performance, and also explaining dev tools a little bit better and giving the tools you need to make your sites continue to stay interactive and fast. Thanks so much, everybody.